Hey guys, welcome back again. I hope you are doing well. Let's see today's questions. Yeah, let's start with the lead code. Minimum cost of buying candies with discount. So a shop is selling candies at you know at a discount. For every two candies sold, the shop gives a third candy for free. The customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of two candies bought. For example, if there are four candies with cost 1, 2, 3, 4, and the customer buy candy with cost 2 and 3, they will get the candy with cost 1 for free, but not the candy with cost 4. Given zero indexed array cost and where cost of I denotes the cost of the higher candy, return the minimum cost of buying all the candies. Okay, so it's showing that if we you know choose any two candies, can choose any candy to take away for free as long as the cost of chosen candy is less than or equal to the minimum of two candies. Okay, if we are trying to buy two candies, okay, then we get a one candy free with the cost minimum less than or equal to the minimum of two candies that we just bought, right? So yeah, in this case, one, two, three, four, and we just purchased the third and the fourth, let's say, then we get the candy with the cost two, okay, for free, but not more than that, something like this. So how to solve this? For example, we have this, we can buy the candies of the cost 2 and 3 and we get this one for free. Okay. Now here we buy the candy of cost 9 and 7, then we get the cost of 6 for free. Then we purchase 5 and 2, then we get the cost of 2 for free. So I guess we need to just buy uh, two candies uh, with the high price, then we get one candy for free, just lower than that price. Okay, so then we get this total cost, right? So one thing is observing that if we have, I guess, okay, uh, let's try. I have something in mind, like let's sort this particular costs. Then in I is equal to 0, let's say, and here we will have minimum cost. Okay, then while I is less than cost or when. Okay. So we can purchase two items, right? And let's start with from back, because when we sort it, then we have the elements, greater elements in the back side, right? and put it here. Okay, and this will be, and this should be greater than equal to 0. Okay, so this is the first item that we have to buy, right? So we can put like minimum cost plus equal to the cost of I. Okay, and since we get one candy for free, right? When we buy 9 and 7, we get 6 candy for free. So we can add like minimum cost plus equal to this should be greater than 2 at least. 0, 1. Okay, 1 at least. So we have this I and I minus 1. Okay. And I guess once we have this particular two item, okay, then we can directly go to the, you know, like this I minus equal to the meaning, uh, you know. So for example, we have I is equal to 1 here, then this 1 and 0 we calculated. Now we need to shift on the, this particular index I minus 2, which is 1 minus 2 minus 1. Return min cost. What is this? 97652. 97652. If we buy these two items first, let me do the index. Okay. If we buy this item first, our I is 5, right? So we put 9 and 7, meaning 5 and 6. Now minus 2, right? Which becomes 3. 5 minus 2, 3. Now instead of 5 minus 3, it should be 3, right? Let's try this again. Since might happen, we have only one candy, okay, and that we have to get it, right? So instead of, I guess, if only one candy we can handle from here. Let me check the array. Okay. Now let's try. Now again what? If we purchase these two items, we get this one. 6. Uh, okay. If we purchase these two items, our budget will be 600. You know, then we get this three, and then we have to jump for this. Okay. So I think I should do something like, okay. So for every third character that we have to ignore, like meaning that if we have this particular stuff, okay, we have to consider this and ignore this one. When we have consider this, ignore this one. Okay. Okay. And main cost plus equal to the cost of I. Okay. And if I minus is greater than equal to 0, cost plus equal to cost of I. Once we have these items, okay, then we need to do that, right? So we have to do like I minus 1. Okay. Meaning now it will work. Okay. So we have this one and then this one. Okay. Since I minus 1 is greater than equal to this, so we have 5 and we get this one for free. So this one for free. Okay. Meaning this two should be here. Great. Now let's okay, it passed. Now GFG. Product can be the single element also. And we have not it. Okay. Then uh, node is this one. Okay. Now what I need uh okay. If in the array, okay, uh if there is 0, we have to ignore it. And yeah, might happen that I'll be we need to count, right? So let's say if the array has odd negatives, then we actually don't need to do extra stuff. Whatever the product we have, just return it, excluding zeros. So always exclude zeros. Okay. And might happen that array contains every element as a 0. So let's see uh, 0 down and negative down. We need max negative. Okay. If it contains the odd number of negatives, then we have to remove the uh, max negative from it. Meaning, you can see for this, let's say we have only uh, let's say we have only this array. Okay, so this the count of odd negative is 1 and the maximum negative is -2, right? But in this case, the maximum negative is -1. But since it's not odd, then we're not going to remove it. Something like this. So let's have the long product pause and I 0, or we can say num from array. If num is equal to 0, then 0 and plus plus and continue. And if num is negative, then negative and plus plus, and I need to track the max negative, right? Max negative or and get the product. Product. So I don't know, it's not below not is 40. Okay. And if 0 count is equal to n, then return 0 because every element are zeros. And next what? If negative count if negative count is 0 in this case, if negative count is 0, return the product. Now what? If negative count is uh, odd, right? That will go to is not equal to 0. Anyway, we are odd negative. So we need to remove the max negative from it. Okay. Uh, okay. We need to remove the max negative from it. Uh, we have this product again. Again, I come from array, and if num is equal to 0, continue. If none is equal to the max negative, then okay, might happen that the max negative has duplicates. Okay, so we need a boolean. Remove, let's say, and remove and what? Continue. So here we need to check the thing. And product is equal to product into none, and this is not okay, and return product. Okay, let's see what's happening. negative count, Lucy conversion. Okay, here we need to print. It's showing minus 24. Okay, okay. The max negative among this is -1. So when -1 comes into the picture, I'm not trying to get into the product, but still, how? So -1. Mm, negative count. Where product? Let's check the outcome. Print LM. This particular number. So we have a -1 and need to check max negative. What is max negative? Max negative is 0. How? Okay, I have to by integer min value. Then it will have the max negative -1 of 8 containers. Now, is there something that we are missing? Okay, our first observation, we ignore zeros. Second observation, array might contain all zeros. That is why we determine 0. Now, third observation might have the odd number of negatives. In that case, remove the maximum negative from the array, meaning in terms of absolute value, we're removing the minimum positive numbers in terms of absolute, minimum absolute number of negative. Okay, so is there something that we are missing? Okay, uh, let's see what happens. -1. Okay, might have only one item of negative and okay, something like if negative count is 1, let's say, then we cannot do about this, right? And might have other only zeros. In that case, the 0 will be the answer, right? Uh, let's check we have 2 and 0. Sorry, we need to do something about this. If the negative count is only 1, in that case, it's written the hold on. And this will be like okay. If negative count is only 1, then we should ignore it. But when not, the negative count is mm, equal to n, let's say. But then again, if it's 1, then we are, you know, calculating this much stuff, right? But what happens if there is 0 and, something like 1 minus 1, 0, 0, 0, 0, then the answer will be uh, -1 since we are not including zeros into it. Okay. So, in this case, the answer should be 0, right? Mm, let's say if the negative count is 1 plus 0 count is equal to n, meaning that we return 0 only. Okay. And here we need to do this thing. If n is equal to 1, return an array of C, whatever we have. Okay. Let's try this. Okay, it's working.